So we have to identify the six trig ratios for the angle T. So this is our angle T. 33 is opposite. So this is the opposite side. 56 is adjacent. And 65 is your hypotenuse. So remember, sine is opposite of hypotenuse. So the sine of angle T is going to equal opposite.
Miss Bryant,
Yes,
you're like muffled.
I'm muffled. Thank you so much. Why Oh, okay. What about now? Am I still muffled?
No, you good.
Okay, thank you. So the sine of angle T is going to equal opposite over hypotenuse, which is 33 over 65, which cannot be reduced. And then I automatically do the sister. So the sister of sine is cosecant. So cosecant of angle T is the reciprocal, which is 65 over 33. And then next is cosine of angle T. So cosine is adjacent over hypotenuse. And the sister to cosine is the secant. And again, we went over these abbreviations. I believe that was Friday. So secant is the reciprocal, which would be 65 over 56. And then the 5th and 6th are tangent. Tangent is opposite over adjacent. And cotangent is the reciprocal, 56 over 33. And that would be your 6 trig ratios. So go back, if you weren't in class Friday, go back and watch that recording. It is posted for you to watch, where I went through all 6 trig ratios. So I wanted to continue in homework 2, practicing in homework 2. So take a minute. And we're going to look at number 47. So this is the unit circle. And remember, I always say, so the unit circle is your calculator. So we have to find the exact values of all 6 ratios for 2 pi over 3. So for number 47, 2 pi over 3. So the first thing you would have to know is, well, what is the sine and cosine of 2 pi over 3? And that is on the unit circle. So I actually copied and pasted the unit circle on the screen. Here is 2 pi over 3. So we are going to focus in on this right here. This is the angle on the unit circle that we're looking at. So we have to do all 6 ratios or all 6 exact values for 2 pi over 3. 2 pi over 3 is equivalent to 120 degrees. So 2 of the 6 are given to you immediately. So let's start off with cosine. So the cosine of 2 pi over 3 is your x value, which is -1/2. And let's do its sister. which is the secant. Secant is the reciprocal of -1/2, which is just -2/1, or just -2. So all of these x values on the unit circle, that's your cosine. And all of the y values are sine. So now we can do sine and its sister. So the sine, and actually too, I'm going to write these at the top. So the cosine of 2 pi over 3 is -1/2, and the secant is -2. So now let's do the sine. So the sine of 2 pi over 3 is your y value, which is just the square root of 3 over 2. So in quadrant 2, cosine is negative and sine is positive. So my sine and its sister will be positive in quadrant 2. So the sine is √3 over 2. Now, though, to find the sister, which is the cosecant, we have to flip that. And when we flip it, we can't have a radical in our denominator. So for this one, we got to multiply it top and bottom by √3. So when we do this, we get 2 √3 over the square root of 9, because 3 times 3 is 9. And that's a perfect square. So it just becomes a 3. So we no longer have a square root in our denominator. So the cosecant of 2 pi over 3 equals 2 √3 over 3. And then the tangent, well, tangent is going to equal sine divided by cosine. So this is the one, though they're called our quotient ratios because we have to actually divide. So we're going to take the sine, which is our y value. So that would be the square root of 3 over 2. And divide that by cosine, which is -1/2. So we have to do that keep, change, flip. So I'm going to keep, change, flip. And our 2's go away. And we're just left with a -√3 over 1. And anytime there's a 1 in your denominator, you can drop that 1. So for tangent of 2 pi over 3, it's just -√3. And now cotangent, well, cotangent is equal to the reverse. So instead of sine divided by cosine, is cosine divided by sine. So cosine is -1/2, and sine is positive √3/2. So we do our keep, change, flip. Which gives us -1/3, which we can't leave. So we have to multiply by the √3. And we end up with a -1√3/9, which is actually, which is not really an or, which equals -√3/3. And that would be the cotangent. And that is what you're going to have to do. So I picked one of the examples in the homework where they give you an angle and you have to go to the unit circle and answer all 6. So that is how you will do that. Any questions about how we found any of the 6? And that's why I keep saying that knowing the unit circle is going to be really, really important, because it is essentially your calculator.
I have a question.
Yes.
So last Friday when we wrote like the sine is equal to y/r, like what did those mean? And like
So good
r
question.
y.
Okay, so you see on the unit circle, these are all triangles. So this is, for example, I'm gonna draw a triangle here. So this would be your R, that's your radius. Okay, your Y and your X. But if we go back to what we covered in going way back to geometry, R can also be another way to think of R is your hypotenuse. Another way to think of Y is opposite, and X is your adjacent. So if you relate that to the unit circle, just know that R is your hypotenuse, Y is opposite, and X is adjacent. Because I don't know if you see this right triangle right here. Okay, the opposite is your vertical distance, which is your Y. Your X, or your adjacent, is your horizontal distance, which is why we use X, because it's your horizontal change. And it doesn't matter where I drew. So I drew it here, but if I were to draw my right triangle for the example that we just did, oh, that was a bad one. Hold on. See this triangle here? This is theta. Theta is always closest to the origin. Same thing, this would be your radius, which is your hypotenuse. This is your Y, and this is your X. And because this is a 30, 60, 90 triangle, your hypotenuse, well, this is where these are coming from, because they had to be rationalized. But it's coming from the ratios you learned in geometry. So in the notes that you wrote down Friday, just think of R, and you can write this down. R is your hypotenuse, X is your adjacent, and Y is the opposite.
Thank you.
You're welcome. Any other questions before we move on to the next homework question? Which I'm not quite sure. Let's see if we have time. Oh, yeah, we do. All right, go ahead and copy this down, number 77. This is also a homework question. So this is from the textbook, question number 77. But before you do anything, you have to figure out what quadrant, let me write this down. What quadrant are we in? Because this is not an angle per se, because we don't have this on our unit circle. Like there is no -3, 4. We don't have a cosine of -3 and a sine of 4. But what quadrant would we be in? And you could tell me in the chat where you have, there's only one quadrant that it could be, where X is negative and Y is positive. Because that's what you want to start off by figuring out. Is which quadrant has an X that is negative and a Y that is positive. It is quadrant 2. Thank you. Quadrant 2. So I already know that this is where I am. I'm in this quadrant. So, because we have to do all 6. So in this quadrant, sine what is positive in quadrant 2. My positive values are sine and its sister. That's what's positive. Everything else is negative. So that's kind of important though, because we also need to make sure we assign the right value or the right sign, positive or negative, okay? So remember again, this is X, this is your Y, X is adjacent, Y is opposite. We need to figure out the hypotenuse. And it is a right triangle. So we can use the Pythagorean Theorem. So C squared is going to equal A squared plus B squared. So I'll go ahead and solve that. So if you were to draw this out, well, actually, hold on, let me rotate that. So if it's in quadrant 2, it's going to face like this. And I'm putting the negative there, but when we're talking about a distance, we usually, well, we do ignore the negative. But go ahead and use Pythagorean theorem to find C. So C squared is going to equal 9 plus 16, which is 25. And if you take the square root of 25, you get 5. So this is actually just like the Bell work, where I gave you a right triangle and I asked you for all 6. So let's start off with the sine. And I'm just going to call it theta, because I don't know what this angle is. It's not an angle on the unit circle, but it's some angle. You could say X, you could say Y. Well, let's not say X or Y because that's sine and cosine. But I'm just going to use theta because theta is a very common variable that's used for an angle. So sine is equal to opposite over hypotenuse, which is 4/5. And then let's do the sister, which is cosecant, which is 5/4. Those are the only 2 that should be positive, because in quadrant 2, that's all that's positive. The other 4 are going to be negative. We have to put a negative sign in with it. So we have the cosine of theta, which is the adjacent over the hypotenuse. And then its sister is the secant, which is the reciprocal. And then we have the tangent, which is opposite over adjacent. And the sister, which is the cotangent, which is the reciprocal. That negative sign can go anywhere. Here, let me go ahead and put that in front for my tangent. There we go. As long as it's negative. That would be your 6 values. Okay. So we started the homework. And again, I'm going to add a link where it says due date so that you all can submit this homework assignment. So what I did was I picked one of each kind of question in the homework for you to kind of look at. That's actually all I have for you for today. I'll stay on for a few moments if you have questions. If you need a book, you can come up and grab a book. Even though we're virtual, you can still come to the building and grab a book. That's not a problem. You can just stay on and let me know if you're planning to come up today, and I'll make sure I have the book ready for you. Other than that, have a great day, and I'll see you in class tomorrow.